So, good evening, everyone. My name is Kosik Mato. I am from West Bengal and I am currently pursuing my Bachelor of Technology in Electrical Engineering from Haldia Institute of Technology. In the last few months, I have completed my Emertxe internship on embedded system. So, my project name is Washing Machine Simulation. My mentor during this internship is Guha Priya ma'am. So let's continue the introduction. This presentation outlines a project focused on developing a washing machine system using embedded technology. How a washing machine works, you, that will using embedded system, we will going to simulate that. It will cover the methodologies, tools, and components. This project will cover how tools are used and how many components, how many tools are used in this that will show in this project involved in creating a functional embedded system. Tools used. I have basically used three tools in this project, and these three tools are main tools. So first of all, MPLAB XC8 compiler. If you don't have this compiler, you can't compile the codes in the MPLAB IDE. So MPLAB XC8 compiler is very important in this project. And my another tool is MPLAB XIDE. This is the IDE and programmable tool where we program all the C codes in the for the project. All the header files, all the source files we have stored in the MPLAB IDE. In the MPLAB IDE, when we completed our course, there will be a hex file generated, and that hex file we have to put in the in PICSimLab PIC16 F877A. So after compiling all the codes in the MPLAB IDE, we we can simulate the PICSimLab. Otherwise, if you can't have hex file, you can't generate or implement the codes in the PICSimLab. Introduction to embedded system. Embedded systems are specialized computing systems that perform dedicated function within larger mechanical or electrical systems. That means it works in mechanical or electrical systems. They integrate software or hardware components. So basically, embedded system integrates software and hardware components both to enhance the performance and efficiency. The washing machine project examples the practical applications of embedded system. In the washing machine project, we will learn how the embedded system practically works. That shows the washing machine project, showcasing innovative design and implementation. Purpose of the washing machine project. So the primary objective of the washing machine project is to automate the washing process. So our primary objective in the washing machine project is to automate the washing process, ensuring user convenience and energy efficiency. It will mm, it will increase the efficiency of the program. This project aims to develop a reliable control system using PIC16 F877A microcontroller. So PIC16 F877A, it is a microcontroller. enabling programmable settings and real-time monitoring for optimal washing performance. So this is the purpose of our washing machine project. Overview of the components used. In the washing machine project using embedded system, the washing machine project utilizes several key components. We have used several key components in this. So some of the components are including PIC16F877A. In the PICSimLab, this is the one of component. Microcontroller for control logic, sensors for monitoring water levels. Sensors mean there is, you can say, the buzzer, that is one type of sensor. When the code has finished or the program has finished, the buzzer has beep or beep. So that is one type of sensor. Monitoring water levels, the water levels is high, low or medium. The load, the actuators are operating the motor. These components works in harmony to create an efficient, responsive system that automates the washing process. Some another components are CLCD display and the fan. These are also the components in our project. So if we briefly explain our compiler XC8, MPLAB XC8. MPLAB XC8 is a comprehensive compiler designed for 8-bit PIC and PIC32 controllers. This MPLAB XC8 is a comprehensive compiler designed only for 8-bit PIC and PIC32 controllers. It supports C programming and offers optimizing options to enhance performance. So we know that in the MPLAB IDE we use C programming. So there is one compiler is needed to compile the C programming. So MPLAB's XC8 is good for C compiler. Key features include code generation, user-friendly interfaces, and extensive library support for peripheral functions, making it ideal for embedded system development. Using MPLAB XIDE. MPLAB XIDE is an integrated development environment featuring a modern interface for embedded application development. It supports project management, code editing, and debugging capabilities. Users can easily configure settings and build projects, streamlining the development process and enabling efficient collaboration among team members. Introduction to PICSimLab simulator. So, PICSimLab is a powerful simulation tool especially designed for PIC microcontrollers. PIC microcontrollers or PIC16 F877A. It provides a virtual environment to test and debug the embedded applications without the need for physical hardware. Users can visualize circuit designs, monitor outputs, and simulate real-world conditions and enhancing the reliability of the software before developing. So PICSimLab, in the PICSimLab we have used the PIC16F877A. Now using MPLAB IDE, we have to implement our codes in the washing machine simulation. In the washing machine simulation, I have used several types of header files and Several types of source files. Several types of header files include CLCD.h. This is the code of that CLCD.h. This is a header file. I am showing you by building the code. You can see that the build successfully. And another header file is digital keypad.h. This is the code of that. I am building that. You can see the code is built successfully. Another header file is main.h. This is my another header file. And this is timers.h. And another the last header file is washing machine function def.h. So these are my header files. I have successfully run all these header files, and these all are runs successfully and built successfully. My source files are clcd.c. .c means this is the source file. Mm, you can see my source file include these codes. It is also successfully built. My another source file is digital keypad.c. These are the codes of that built successfully. isr.c. And another source file is main.c. Include main.h and program configure wtt is equal to off. This is my void main, and this is I run some loops in that, and I have used some break functions. This is also built successfully. My another source file is timers.c. It is defined as the timers, how time is works, that defines the timers.c. Washing machine function .c. This is my another source file. Here also I have include some loops and some break functions. In that source file I have included 2 main points. When the switch 5 is pressed, then the program will start, and when the switch 6 means RB5 is pressed, then the program will pause. When the program completed, when the program completed, the door will close, and in the initial point, doors will open. And another function in this is when the washing machine function completed, it in the LCD display, it shows that program will complete and remove clothes, and buzzer will on. Many types of functions in this. it is also successfully built. You can see that. So these are my source files and header files. I have successfully built all these files. So after that I am going to implement my all this. It all hex files are saved successfully in my file. That hex file I am going to implement in the PICSimLab PIC16 F877A. So see you there. So now after implementing all the codes in the MPLAB IDE, I have to implement my all the hex files in the PICSimLab PIC16 F877A. So here is showing that file. There is one option is load the hex. The hex generated in the MPLAB X IDE, we have to load that hex file in that PICSimLab. So this is my stored washing machine hex file. I have to select that, and this is automatically loaded. So after loading the hex file, there it's showing press key 5 to power on the washing machine. In the PICSimLab, um, key 5 means RB4 button. So when you click the RB4 button, you can see the powering on the washing machine after clicking the RB4 button. So after clicking the RB4 button, it is showing that washing program daily heavy dedicates. So for scrolling down, you have to click the RB3 button. You can see that whites and strain wash and eco cottons and then woolens, then bed sheets, then rinse plus dry, then dry only, then wash only. You have to click that RB3 button one by one so that it will scroll down. Aqua store, daily, and heavy again. So you have to select one point. For selecting one point, you have to long press RB3 button. I am selecting the strain was, so I have long press on the strain was. So you can see after clicking long press on the RB3 button, there is showing on the LCD panel water level auto, low, medium. For scrolling down, you have to again press the RB3 button, high, max, auto, low, again medium, again high. So for selecting one point, you have to long press the RB3 button. I am selecting high, so I am long pressing the high button. After long press of high, you can see there is another window comes. Switch 5 start and switch 6 stop. Switch 5 means RB4 button and switch 6 means RB5 button. So I am going to start the program. So I have to click the RB4 button. So program function has started. You can see the wash is happening in the washing machine. After the timer is on, you can pause the system by clicking the switch 6. I have clicked the RB5 button, and then the washing machine has stopped. Again, if I have pressed the RB4 button, the program will start. Function was is happening. It is strain was, that's why taking some much time. If you select some daily or something else, rinse or dry only, yeah, or was only, then it will take some less time. You can see the was function change to the rinse. The rinse function automatically change to the spin. You can see there is a buzzer in front of the mm, fan. So when the timer will reach to the 0, the buzzer will beep and the LCD panel will show that the program has completed. You can see rinse will change to the spin. Program completed, remove clothes. You saw there the program has completed and buzzer beep when the program has completed. So this is the simulation of PICSimLab using PIC16F877A. Now the conclusion of my washing machine project. The washing machine project exemplifies the effective use of embedded system, enabling automation and improved user experience, utilizing development tools such as MPLAB, XC8 compiler, MPLAB XIDE, and PICSimLab simulator ensures a streamlined process from design to execution, delivering a robust and efficient washing solution. So these are the conclusion. Thank you.